Okay, then last but not least, we have different types of databases, and we will learn about one particular type today, and it's the relational database. So now we have seen how generally a database is structured into different layers, and how it can ensure application independent access, and how it can ensure hiding complexity and stuff like that. But we also have different types of databases for different purposes, or different types of data maybe. And this is an attempt to visualize that. So basically we can say, okay, we can choose a database based on the structure of the data. And if we have very structured data, this is this end, then relational databases are a good fit, because relational databases, as we'll learn in a second, can only handle structured data, such as we find it in spreadsheets. If we have something in in the middle, it's not completely unstructured, but it has unstructured elements, then something like a document database or a NoSQL DB, which we won't go into detail now, but this would be a suitable solution. And if we have a completely unstructured environment where we do not know anything about the data before we store it, we use basically we can use file systems and do something what we call files in addition with schema on read. So we only apply a schema or a structure to the data when we want to do something with the data. Before we do something with the data, it's simply stored in files as they come. So for example, large folders of images with no schema or no structure projected onto it until we want to do something with that data. And then we need to think about, okay, what could be a structure that we project onto that data. So this is the scale here. Very structured data, good fit for relational databases. Very unstructured data, basically file system plus schema on read. And that could be Apache Hadoop, which is basically a big data solution for unstructured data. Then we could have a distinction by the purpose that we want our database to fulfill. So we could have the need to manage data, and by manage we mean change data, update data, delete records. So the typical things that we do in an ERP system. We open a data record, we change, we save it again. Typical thing that we do in so-called operational information systems, where we have people working with the data, changing it and storing it again. So that's managing data. And then here relational databases are once again a very good fit, because they allow us to perform all these 4 CRUD operations: create, read, update, and delete. And they also allow us to change data using transaction, and that ensures that we have consistency in our data. So it's a very focused on managing data. When we have, on the other hand, no need to manage the data, but only to analyze large data sets, or not, it doesn't have to be large, but often it's large. So we have a lot of data, and we simply want to derive insights from that data. And for that, we only need to read the data. We don't need to change it. So we have the data. Let's say we have 10 years of online sales. It could be a large data set. We do not want to change that data because it's history. It's gone. So there's no need to change it. But instead, we want to derive insights from it. We want to analyze it. And then we only need read access. And for that, we have columnar databases or in-memory databases, which is basically similar to relational databases, but they abandon the need to so there's no focus on data consistency anymore, because we don't change anything. Instead, we focus on providing performance by loading the data into memory. Memory, as you might know, is very fast. So everything that is in computer memory can be accessed very, very fast. When it's on a disk, we need some time to read it from the disk. And these so-called in-memory databases, they focus on quick access to the data and loading it into memory, but they lack the means to ensure transactional correctness and consistency, because they just they're not made for writing or changing data anymore. It's just for reading. All right, then by velocity, you can distinguish databases. Basically, that's just because there's one specific type of databases for very fast data. So by fast data, we mean data that is created in a very high frequency. Typical examples are sensor data in Industry 4.0 environment, where we have machines with sensors and we have a very high frequency in which the data is created, like milliseconds or seconds. And we want to analyze that in real time or near real time. Then there's certain types of databases like queues or streaming databases that can achieve that. Traditional databases, relational database, not a good fit for that. And then finally, if we have a very large volume, the fourth category distinguishes databases just by volume. So how many bytes we want to store. Then we can make a distinction between anything from here, and if we get real big, then we need a distributed file system and a distributed database. And distributed databases, we won't go into detail here, but they are designed to scale horizontally very easily. So you simply add a new server and you can store more data, and it is stored redundantly. And Apache Hadoop or Amazon S3 in the cloud are examples of that, where you can basically store unlimited amounts of data. It's simply a matter of scaling and cost, of course. So it will become costly, but it's basically unlimited in terms of data volume or size. Okay, so here we focus on relational databases because we want to focus on managing data or information, and we mainly focus on structured data, and that's why we stick to relational databases.